Welcome to example number 2. We have another office building, some general story in this office building. The only difference compared to example number 1 is the dimensions are different. This general story measures 60 meters long by 20 meters wide. And we're being asked to determine the minimum width of the public corridor that these suites share according to the contents of section 3.3 of Division B of the Ontario Building Code. We're going to be using the same 6 steps that we did for example number 1. So we're going to start with step number 1, which is determining whether or not this is a part 3 or a part 9 building. We're going to use the requirements in article 1.3.3.3 under sentence 1 in division A of the Ontario Building Code, the 3 conditions. And even if one of those conditions fails, it automatically makes this a part 3 building. So we're going to check building height first. Is it less than or equal to 3 stories? We don't know. There's no information given, so we have to skip this. How about the area? Is it less than or equal to 600 square meters? Our area is 60 by 20 equals 1200 square meters, so this condition fails. Automatically, we don't even have to check the third condition right here. We know that it is not a part 9 building. Instead, it is a part 3 building. Amazing. So that means we can use part 3 of the Ontario Building Code and we can move on to step 2. For step 2, we have to determine the major occupancy of this building. And again, don't forget, we want to start with Appendix A because we're new at the Ontario Building Code and then move on to Table 3.1.2.1 under Division B of the Ontario Building Code. Just like we did for example number 1, we found that this building is a D major occupancy, which is business and personal services. Check example number 1 for how we got here. Moving on then onto step number 3. In step number 3, we have to determine the occupant load, which is the ratio of the area divided by the occupant load factor. The area, we've already found that out to be 1,200 meters squared. The occupant load factor, we previously calculated this in example 1. So go back to it to see how we got this number. We put that number in the denominator. So if we do 1,200 meters squared divided by 9.3 meters squared per person, we get 129.03 people. And because human beings are whole number, that means we have to round up to 130. Again, don't forget you round up because people are whole numbers. Awesome. We're ready to move on to step number 4. For step number 4, we have to come up with the minimum width of this public corridor based on the requirements for one single human being to get through. This is the minimum geometric width, and it cannot be any smaller than this. We already did this for example number 1. Because it's a D major occupancy and we're looking for the corridor, according to what's in your course notes and the lecture video, we want to use the contents of sentence 3.3.1.9.1, which says that the minimum width for a public corridor must be 1,100 millimeters. Great. Let's move on to step number 5. In step number 5, we're going to calculate the minimum width of that corridor based on the occupant load, which we found under step number 3. Okay? So the occupant load that we got under step number 3 was 130 people. And based on what we get from the course notes and the lecture video, we find the factor per person for a public corridor under Division B, Sentence 3.3.1.17.2, which is 6.1 millimeters per person. So if we do 130 people times 6.1 millimeters per person, we get 793 millimeters. We round up to the nearest millimeter. It just turns out that this works out to the nearest millimeter. So 793 millimeters. We're ready to now wrap it up with step number 6. Under step number 6, we have to compare the 2 widths you got. The one for one person and the one for all people. So we have to compare 1,100 millimeters and 793, and we always pick the larger one of the 2. So the minimum width of this public corridor in this specific case is 1,100 millimeters, and that's our final answer.